Hello, this is George, and this is a follow-up of my previous video on the graph method of linear programming, and this is going to be on the simplex method. So, the simplex method is a follow-on of the graph method, where you do the same as before, where you define your decision variables, your objective function, and your constraints, and then once you've done that, you can turn these into equations using slack variables. Once you've done that, you can put those equations into a table called a simplex tableau. The benefits of this table are that you can determine if a particular vertex point on the edge of a feasible region is optimal. So like for a graph, it'd be the points where the lines cross. You determine whether that point is optimal or not. And then you use it to decide which adjacent vertex you should move to in order to increase the value of the objective function. It's a simple method, can get quite repetitive. You might have to do it several times to get an optimal solution, but it's much more reliable than the graph method. So I'll explain the method in its simplest form, which is for a maximizing linear programming problem where the constraints are given as inequalities. So to start, we create the initial tableau, which will look something like this. Well, this is a blank one, and you can see the variables along the top row. You've got three variables x, y, z, and then the slack variables r, s, and t. The objective row is the bottom row on the bottom. So we'll look along that row at the bottom to find the most negative entry, so the lowest number, and that will be the pivot column. So say for example the most negative entry is in the z column, and I've highlighted that there, and you can see that I've put in values to help show what's going on. So we're going to use this to calculate theta values, which will be the term in the value column divided by the term in the pivot column. This is going to help us find the pivot row, which will give us the pivot. So what we're going to do now is use the row operation column on the far right to calculate theta values. So we're dividing the value column by the term in the pivot column. So d by a, e divided by b, f divided by c. So what we're looking for is the row with the smallest positive theta value, and that will be the pivot row. So say for example again that the S row was had the smallest positive theta value. So that will now become the pivot row. As you can see there, I've highlighted it there, and I've put more values in to show again what's going on. So the point where the row and the column cross, B, is going to be the pivot element. So what we do now is we'll divide every element of the row by B. So the pivot will now be B1, and everything will be divided by B. At this point, we want to change the basic variable at the start of the row to the variable at the top of the pivot column. And now we can use the pivot row to perform row operations on the other rows, so we can reduce it. So we eliminate the elements in the other rows of the pivot column. So the pivot column will just be 1 as a pivot element, and the other elements in the pivot column will all be zeros. Now we don't know if this is an optimal solution, since, as you can see, the question marks there are all calculated from row operations, and there could still be negative values in the objective row at the bottom. So at this point we repeat the process until there are no more negative numbers in the objective row. And so the tableau is optimal, and at this point so when that happens, the tableau is optimal and the non-zero values can be read off using the basic variable column and the value column. So say this was an optimal solution, the variables of the solution would be r, z, and t, and they'll have the values, whatever values are in the value column for that thing, and then the other variables which are not in the basic variable column will just be 0. So here's an example of a linear programming problem in Tableau form. As you can see, the data has already been put into the simplex tableau. So to start, we're going to look in the objective row, and we're going to see that -4 is the most negative entry in that row. We're going to highlight that there. So we're going to use that to calculate our theta values in the row operations column on the right. We can see that the smallest positive theta value is the S row, so we now know that the pivot element is 6 there. So now we're going to divide the row by that element and change the basic variable on the right, on the left hand side to y. So divide everything by 6. So now we're going to use row operations to get rid of all of the other elements in the pivot column. So as you can see, there's another. This is not an optimal solution. There's still another negative element in the objective row on the bottom, -1 in the z. So we're going to perform another iteration of the method, but I'm not going to go through that. So here's after that, after one more iteration. This is what you get. So now we can see that the tableau is optimal. There's no negative values in the objective row on the bottom, and we have an optimal solution here, where p is 150, x is 0, y is 1.5, z is 48, r is 0, s is 0, and t is 264. This has been a small introduction to the Simplex tableau method of linear programming. Thank you very much.